In this section, we're going to take a look at skin versus core temperature pathways. So the different thermoreceptors that inform the hypothalamus and inform the brain's thermostat on how to modulate temperature. So the core temperature has thermoreceptors deep inside the body. So they're found in the hypothalamus, spinal cord, abdomen, large blood vessels. They're highly sensitive to small changes in blood temperature. Now, what's important to note is when we talk about core temperature, even small deviations, so we're talking fractions, just decimal points of Celsius or Fahrenheit, do have a significant effect. So the window is relatively small. So if you start talking about 0.2, 0.3 Celsius, that is actually a significant amount. And these play the dominant role in maintaining thermal homeostasis. So you can consider them as the set point sensors. So they are really the ones that are set at this, thermostat is a perfect example for this. And then they will help to initiate thermoregulatory responses when needed. So sweating, blood flow, behavioral changes, a lot of that is driven by the core thermoreceptors. Now, there's also the peripheral thermoreceptors. This is what you see in the skin in your hands, your skin in your arms, and your feet. Now, they are located in both the glabrous and the non-glabrous skin, essentially saying throughout the entire body. There's cold receptors, warm receptors. They respond differently. We also see differences in thermal sensitivity between men and women, and they respond to changes in the environment and exposure. So these are sort of that first look before the core changes of what's different in the environment, and then sending those signals, that information back to the brain. Now, they play a lesser role in defending internal temperature, but they're very critical for a few different things. First is initiating anticipatory responses. So hot and cold environments. Great example of this is you learn really young as a kid, touch a hot pan, you learn very quickly what's hot, also cold. So we see this a lot. Winter is a great example. You're going to have vasoconstriction in your hands and feet, and that's why you're going to end up getting frostbite, because your body can't afford to have those portals open in those areas with really, really high levels of heat transfer, because you could dump heat way too fast to the body and get hypothermia very quickly. And then behavioral choices. And I think this is probably quite intuitive and quite obvious that you feel the ambient environment either too hot, too cold, and behaviorally responds accordingly. Now, all of this is integrated centrally in the hypothalamus. So the core signals come in, skin signals come in, and through some magic, brilliant human design and algorithm, the body is able to assess the situation and respond accordingly. And this is really all, as we talk about this section, building the foundation of why central fatigue and why the brain, the thermostat, the subconscious thermoregulatory responses really precede what we're able to do voluntarily and consciously in terms of performance, because the body is operating in the background, and temperature really sets the foundation for what the body is and is unable to do. So practical implications for this is that, first of all, it's important to note that skin temperature may be misleading. So even if you can feel cool or you can be exposed to cold surfaces or cold contact, that does not necessarily correlate to changes in core temperature, changes in thermoregulation, or changes in performance. So putting an example is putting an ice pack or an ice towel to the neck may feel really nice. There may be perceptual changes, but there may be very, very minimal, if at all, changes to core temperature and to the actual homeostasis of the body, and then the downstream performance implications. Also, rapid environmental changes can cause perceptual shifts, but again, there's a delay in physiology. You will receive these environmental cues before you'll have changes in the core temperature. There's a lot of moving pieces involved. So as we get further into this course, it's to really understand that core temperature and the core of homeostasis is what matters. And so when we look at cooling strategies or programming mitigation strategies, we want to focus on how can we optimize core temperature to stay in the optimal zone, less so concerned with skin or peripheral temperature.